So today we're going to learn about end behavior. That is what happens to the y values as x approaches infinity and negative infinity. A turning point is where the graph changes from increasing to decreasing and vice versa. And then there's maximum and minimums. A local max and min is the highest or lowest point in a particular area, and the absolute would be the highest or lowest on the entire graph. So example 1, write the end behavior and label the turning points and all the maxes and mins. So I'm going to do turning points first. So I'm going to use a color coding system. So I'm going to label all the turning points in red. So a turning point, if you're just going to trace the graph from left to right, just like we did in the last video, and wherever it goes from up to down or down to up, that's where it changes direction, like right there. And then I'm going to be tracing it, and it'll be changing direction right there, and then here. That right there is not a turning point because I am decreasing before that, and I continue to decrease after that. That's a turning point. That is one. That's one. All these are turning points. So on an axis, you would label the ordered pair. So then I'm going to do the absolute and local maxes and mins. So I'm going to use blue and make that my absolute max. So absolute max would be the absolute tallest point, and that would be right there. And then I'll do absolute min. I'll make that green. And that would be the absolute lowest point, which I would say is right there. So now locals. Every turning point has to be a local max or a local min. So for local max, that's basically all of the peaks of the mountains. So this absolute max is also a local max. That's a local max because if you were just going to zoom in on that graph, it would be the tallest point in that area. That is one. That's one. All of these are. So it's all the peaks if that was a mountain range. And then for local mins, that's all of the valleys of the turning points. So that's one, that's one, that's one, that one's, and that one. Okay. So then, oh, and also this one, forgot that one. So then end behavior. So end behavior would change depending on if this was a graph that stopped or a graph that went forever. So let's pretend that it does go forever. So there are arrows on the end. And so if it went forever down, that means that this point down here would no longer be an absolute minimum because you could never pinpoint the absolute lowest point because these ends would keep going on and on forever. All right, but as for the sake of end behavior, let's assume that they are arrows. And so you would write two statements where x is going and where y is going. So in this end to the left here, as that end continues farther and farther down, x is going to be going farther and farther to negative infinity. And as that goes farther and farther down, y will also be going to negative infinity. Over here on this side, as this end continues farther and farther, x is going to be going into the positive infinities, and y is going to be going to the negative infinities. So let's try another one now that has an axis. So for end behavior, you can either write it on the line or you could write it on the graph. So I'm going to show you on the graph. So let's look at this end first. So I do x arrow, y arrow. So if it helps, take that end and drag it down to the axis. And in the axis, I am in the negative x value, so I'm going to negative infinity. And then drag that end to the y-axis, and that is going to positive infinity. Now remember, you might have to extend this arm a little bit just to see and make sure that it doesn't end up going into another infinity. So for this end right here, if I drag that down to my x-axis, I'm in the positive x values. These are all positive values, so positive infinity. If I drag it into my y-axis, it's also in the positive values in the x-axis. So the end behavior is on the graph. Now for turning points. Turning points, I have a turning point here, 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 and here. So all the peaks and the valleys, but we actually need to name them. So if you notice, the axis is skipping by 2's. So this first point down here, that is going to be -3, -4. And then this point up here, I would say is about -2, 3. This point down here, I would say is 0, -1. This one up here, I would say is 2 and maybe 6.5. And then the one down here, I would say is probably 3.5 and -2. Okay, so it doesn't have to be super exact. Now for local maxes and mins, what I suggest is that you get some highlighters and you color code it. So I am going to say that my local max will be a yellow highlighter. Okay, so I'm just going to highlight all the turning points and what they are. So the local maxes would be all the peaks. So that is -2.3 and 2.65. And so then the local mins would be the other ones. It would be all of the valleys. So it would be these three. And then for absolute max and min, I would just write it on the line. So for this, the absolute max, since this graph, both those ends are going up forever, there is no absolute max. But there is an absolute min, and it would be this one right there. So the absolute min would be -3, -4. For number 2, I'm going to write my end behavior on the graph. So x arrow, y arrow. So as s continues forever and ever, it's going to be in the negative x values, negative infinity, and it's going to be in the negative y values. For this end over here, is that end continues on and on and on. That's in the positive x values, and it's in the negative y values. For turning points, there's only one turning point, and that is right here on the axis. So the order pair is 0, 0. That is a local max. So I'm going to color code it as a local max. Oops. All right. And then there is no other turning points, so that means there's no local mins. For absolute max, that 0, 0 would also be the absolute max because it does not go up any further than that. And then there is no absolute min. For the last one, whenever you have these gross rational ones, you only need to do the end behavior for these two ends right there. You don't need to do them from the other two. And so for both of those ends, you have to keep in mind that there is that asymptote. So that asymptote's going to be right in between. Okay, so on the left-hand side, x, as that continues on and on and on, x is in the negative infinities. But y, however, y, this line as it continues is neither going to be going up nor down because of the asymptote. So the y value on these type of graphs for the end behavior is going to be going to a number. And the number is going to be wherever your asymptote is. So in this case, our asymptote looks to be about 2, so y is going to 2. So then on this end, x is going to positive infinity. And y will be going to that asymptote as well at 2. So now for turning points. For this, it is only going down. So if we were going to trace this graph, this one is only going down, and this one's only going down. So if it's only going down or only going up, that means that it would have no turning points. And if it has no turning points, it cannot have any maxes and mins, so you can just put an arrow straight down.